Bismillahirrahmanirrahim. Today, inshallah, we shall continue our discussion of combinations and permutations. Now, if I give you a four-letter word like this over here, poem, if I ask you, I'm going to pick 3 of these 4 letters, and how many different ways can I put those 3 letters together? So, well, the first question is, and you're assuming this, is the letter being repeated or reused or not? That is, if I used P over here, can I reuse it over here like this, or no? So the first question is, can I repeat the letter? If you can repeat the letter, if you pick 1 letter over here, you still have 4 choices over here, and you still have 4 choices over here, right? So the first question you have to ask yourself, if you're picking 3 letters from 4 letters, is the letter that you're picking, is it used up, or are you putting it back? And then you have 4 choices again the next time around. Because if you're repeating the letters, then there are 4 choices for the first spot over here, and then 4 choices for the second spot over here, and there are 4 choices for the third spot over here, like this. So that would be 4 times 4 is 16, 16 times 4 is 32, and 64, like this, right? So if you're repeating the letters, if you're allowed to repeat the letters, then you would have 4 times 4 times 4. But let's say you're not allowed to repeat the letters. Then you have to ask yourself if the 3 letters, the order of the 3 letters makes a difference or not. Because if it does not make a difference, then that scenario, of course, as you realize, is called a combination. All right? And if the order does make a difference, and that this scenario is called a permutation. For example, if I pick POE over here, then if I pick PEO in a combination scenario, if I said, well, how many different combinations of 3 letters of these alphabets I have, this one would not be allowed, because these 2 would be considered the same. Okay, because in combination the order does not matter. So in combination, once you have POE, then all 3 letter combinations of these would not be allowed. For example, POE, right, and then PEO, correct, and OPE and OEP, correct, and EPO and EOP, these are all would be considered to be the same. The combination scenario, we're talking combination of 3 letters, right? The order does not make a difference, kind of like the donuts going in the same box, right? So these all 6 would be considered the same. But in scenario permutation, all of these would be considered distinct, and they would be counted as 1. So that's very important to understand. So in combination scenario, right, the order does not make a difference. Now, what I like to do is I like to show you how you do these with the formulas that we have given, and then I like to show you in the future how these formulas are derived. If you recall from our last discussion, the formula for finding out a combination is this: combination of n choose r equals n factorial over n minus r factorial times r factorial. And the formula for permutation is written like this: permutation of n choose r is n factorial over n minus r factorial. All right, so these are the 2 basic formulas for combination and permutation. Now, these are very intuitive, and if you understand these, if you understand the concept between these, then you'll understand how these formulas are derived, which I'll try to explain to you, inshallah, next time. But first, I like us to get reasonably comfortable using these formulas. All right? So first thing you have to know, of course, is what does factorial mean? The symbol factorial, like this. So factorial means like this, right? So if you have 5 factorial, that means you multiply 5 times 4 times 3 times 2 times 1. So 5 factorial would be 5 times 4 is 20. 20 times 3 is 60. 60 times 2 is 120, like this. Correct? Right? So, and then 7 factorial would be therefore 7 times 6 times 5 times 4 times 3 times 2 times 1, and whatever that product ends up being. As you can see, these numbers get very big very quickly. So if we were to find out how many different combinations and how many different permutations of 3 letters are from a 4-letter word, we would do the following. This scenario would be combination of 4 choices, that's n, combination of n, but you're choosing 3. And here it will be permutation of, we have 4 choices to pick from, permutation of 4, pick 3. Okay? So this would be, and you can say n is 4 and r is 3. So this would be 4 factorial over 4 minus 3 factorial times 3 factorial. And if you just do this, 4 factorial is 4 times 3 times 2 times 1. And then 4 minus 3 is just 1. 1 factorial is just 1. And 3 factorial is 3 times 2 times 1. And as you can see, this will cross off, this will cross off, this will cross off. Correct? So this ends up being only 4 different unique combinations over here. Now, in the same manner, if you have permutations, so you have 4 factorial over 4 minus 3 factorial, right? So this is 4 factorial over 3 and 1 factorial. So this is going to be 4 times 3 times 2 times 1 over 1 factorial is just 1. So that's 4 times 3 is 12. 12 times 2 is 24. So for this, in this particular scenario, there are going to be only 4 combinations of 3-letter words, 3-letter words that you can make from a 4-letter word, and there are going to be 24 different permutations of 3 letters from a 4-letter word. Okay, so this is a simple example of a combination and permutation. Just to remind you, 0 factorial is 1. All right, it's not 0. Okay, now I'd just like to just do some examples just to make sure that you understand these concepts very well. So here's some questions that I found. So Castell and Joe are planning trips to 3 countries. So they're planning to go to 3 countries this year. There are 7 countries in total that they would like to visit. One trip will be 1 week long, another 2 days long, and the other 2 weeks long. So they are planning 3 countries that they will go. There are 7 countries they would like to visit. So now, first question is this a combination problem or is this a permutation problem? Does it matter which order that they pick the trips in? Presumably here it does, because the trips are not the same, they're different. So it makes a difference if they pick the first trip to be 1 week long, and the other one 2 days, and the other 2 weeks. So it makes a difference that how you put these trips together, because the trips are not the same. So this is a permutation question because the order of choices of the trips makes a difference. So how many possibilities you have? So the possibility is 7, and the how many choices you have, you're picking 3. So you would read this as permutation, 7, choose 3. Permutation of 7, choose 3. Now you should have a calculator that does this for you. I pulled this up here for myself. So you have permutation of 7, choose 3, and that's up being 210. So if you do this in a calculator, this would end up being 210. So, but we can set this question up. Let me set number 5 over here. All right. So this is permutation of 7, choose 3. Now, just for practice, I like to just write the formulas down every time I'm doing one of these questions. Permutation formula is n factorial over n minus r factorial. So this is going to be 7 factorial over 7 minus 3 factorial, right? So that's going to be 7 factorial over 7 minus 3 is 4 factorial. So that's going to be 7 times 6 times 5 times 4 times 3 and dot dot dot, and on the bottom is going to be 4 times 3 times 2 dot dot dot. And you can do like those ellipses, because you know everything after the 4 you recognize is going to cancel out, and this apparently will end up being 210, as we said. Now question number 6 here says there are 110 people at a meeting. They each shake hands with everyone else. How many handshakes were there? Now this is a very popular question, because you know it's, first of all, it's kind of cool to understand how many different handshakes are there, because if you have like 5 people like this, okay, and then you see what happens then is, okay, this person shakes hands like this, right? And then then you have the other 5, right? And then this one will shake hands like this. But then you'll see these are the same, correct? So does it matter which they shook hand? They only shake hand one time, right? So you follow what I'm saying? In other words, if you draw these yellow with 5 people, they're like 1, 2, 3, 4 different types of handshakes, right? But then there's this person is going to shake hands with this person, this person, this person, but they already shook hands with this, right? So it doesn't make sense. It's like double handshaking. So which order you do doesn't matter. So this is actually a combination question. So question number 6 is you have 110 people and you're choosing 2 at a time. So combination of 110, pick 2, and the formula for combination is n factorial over n minus r factorial times r factorial. Now I'm going to do this here on my handy dandy calculator, and this is 110, and you're picking 2. That ends up being 5,995. So that's 5,000. So that's 5,995 different unique handshakes. 5,995 unique handshakes. You can figure out how many handshakes there are, in a big Eid celebration or something like that. Okay, let's do number 7. It says you are setting the combination of a 3-digit lock. So you have a lock, and you're setting a 3-digit combination over there. You want to use the numbers 1, 2, 3, but you don't care what order they are in. Okay, so you don't really care what order they are in. But this is a, I don't know if this is not a fair question or a tricky question, but it's phrased very, very funkily. The reason for that is this. First of all, combination, it's called a combination lock, but it's actually a permutation lock. Locks, right? For example, if you have a lock and the code is like 614, but if you put in 164, is it going to work? No, they're different, unique set of numbers, right? So even though it's called a combination lock, it's actually a permutation lock. Locks are permutations, because if you put the numbers in the wrong order, it's not going to work. So even though it's called a combination lock, they should really be called permutation locks. That's one trick question. And then another trick aspect of this question is you want to use the numbers 1 to 3, but don't care what order they are in. Well, that's your preference that you don't really care. But because somebody might say, I want this to start with 3. Okay, well then that makes a difference. Okay, the fact that you don't care what order they're in doesn't mean that the order does not matter. You follow what I'm saying? That's why it's tricky. Or you don't. The fact that you don't care what the order that they're in means that you have no personal preference that it starts with the first one or second like this. So this is actually a permutation question of you have 3 choices. You only have 3 choices. You only have 1, 2, 3 you're picking from. You're not picking from 1 to 3, 4, 5, 6, 7, 8, 9. You have permutation of 3. Choose 3. Now, it's simply stating, if you have 3 choices for the first one, you have 2 choices for the second one, and you have 1 choice for the third one, and this is 6. Now you can do this using the formula as well. Permutation of n factorial over n minus r factorial. Okay, so this is going to be 3 factorial over 3 minus 3 is 0 factorial, and 0 factorial is not 0, remember. So 0 factorial is 1. So this ends up being 6. Okay, so this is a good question in some ways and kind of tricky in other ways. So and so that's this question. Question number 8, we're kind of running out of room over here, but let's see if we can fit that in. A group of 25 people are going to run a race. The top 8 finishers advance to the finals. So 8 people will advance to the finals. So there are 25 starting, and 8 will go to the. Does it matter in which order these 8 people finish? No, because as long as they're in the top 8, they will advance to the next level. So this is a combination question. Combination is 25. Choose 8. Again, this will be n factorial over n minus r factorial times r factorial. And let's do 25 choose 8. We'll do on this on the calculator over here. Alright, so let's see what this ends up being. 25 choose 8. We'll do on a calculator over here. Combination of 25 choose 8. That's a very big number. That's like 108. It's like 1,081,575 different ways of those people. That's a big number, isn't that right? But it doesn't seem like it would end up being. But that's how many different combinations are there of 8 individuals if you're picking from 25. Okay, now I'd like to show you something. Now let's go back to this word poem. So how many different ways, how many different permutations are there if I have a 4-letter word like this and I'm picking all 4 letters? Well, you can use the permutation formula, permutation of n choose r, which is n factorial over n minus r factorial. But that's what I'm trying to show you, how this formula works. But let's say I have 4-letter word, I'm picking 4 letters out of 4 letters. How many different permutations are there? Well, for the first spot over here, there are 4 options, and then if you're not repeating the word, for the second spot you will only have 3, and then once you use the second letter, you only have 2, and then finally you will only have 1 left for the fourth spot. Now, if you were only picking 3 letters out of the 4, okay, so you would have 4 options for the first spot, and then 3 options for the second spot, and then you would only have 2 options for the third spot, like this. Now let's say if you have 5-letter words, poems, like this. So how many different permutations are there if you were to mix them all these 5 letters? You have 5, you're picking 5. In other words, this is permutation of 5, choose 5. This was permutation of 4, choose 4, and this was permutation of 4, choose 3. So how many different possibilities are there? Well, so this is going to be 5 choices for the first one, 4 choices for the second spot, and then you only have 3 left, 3, 2, 1. And this would be a product of all of these. So, and then if you were only picking 4 letters out of the 5, you would have 5 options for the first one, and then 4 options for the second one, and the third option for the third spot, and 2 options for the fourth spot. So this is like permutation of 5, choose 4. And finally, if I give you this particular example, if you're only picking 3 letters, you would have 5 options for the first one, 4 options for the second one, and 3 options for the third one. So this is like permutation of 5, choose 3. Now you can see over here, I hope you do, that this is like same as n factorial, which is 5 factorial, over you're choosing 5, which is 5 minus 5 factorial, which is 0 times which is 1. And this is in fact 5 factorial divided by 1 factorial, right? Because the 1 is missed, right? And this in fact is 5 factorial over 5 minus 3 factorial, which is 2. So this is 5 factorial over 2 factorial, but 2 factorial being 2 times 1, because that's kind of like missing if you see from over here. So when we do permutations, basically this is what's going on. So now the permutation formula is simply this part of it is simply how many of the alphabets are missing. So if you have let's say a 11-letter word, So if you have an 11 letter word and you're picking 4 of the 11, so 1, 2, 3, 4 out of the 11, then there are 7 spots that you're not picking. 2, 3, 4, 5, 6, 7 spot. So if you have a 11 letter, I don't know an 11 letter word, but if you're picking only 4 out of the 11, how many different permutations are there going to be? Well, they're going to be, if you pick all 11 of them, it could be 11 times 10 times 9 times 8 times 7 times 6 but you're not picking all 11 of them. You're only picking 4. In other words, these are all going to be canceled out. So there's going to be, you have to have n minus r, which would be 7 of them are going to be canceled out, right? So it's going to be 7 factorial on the denominator. So if you appreciate that, then you can see how this formula is derived. This n minus r factorial are basically, so this term over here basically is how many terms you're not picking. You're dividing them out. So these are the terms that you're not picking, so you're dividing them out over there. Now if you appreciate that, then understanding the formula for the combination also makes sense, because if you have combination of n choose r, okay, I suggested to you, if you were going to pick a letter P, I gave you a 3-letter example. So if you pick P-O-E, then you're not going to consider P-E-O another option. Well, how many 3-letter different combinations are there? Well, if you have 3 letters like this, okay, how many different combinations, how many different permutations are there? Well, it's going to be 3 times 2 times 1. It's going to be 6 different ways you can put together 3 letters like this. Okay. In other words, if you have 5 letters and you're only picking 4, right? If you're only picking 4, then how many different 4-letter combinations are going to be considered as 1? For example, you pick O, E, M, S, right? And then you have M-O-E-S. How many different 4-letter combinations there are? Well, that's going to be easy, because that's going to be 4 factorial. And that's why this is n factorial over n minus r factorial. The only difference between combination permutation formula is this little extra r factorial. Now this r factor accounts for how many different ways you can put together however many you're choosing. So if you have combination of 5 and you're picking 4, right, you have to subtract the 4 ways that you can put together 4 letters to give the combinations versus permutations. Now that was for those of you who really want to understand the difference between these two formulas and how they are arrived. But if you're able to use these without completely understanding them, you can leave the understanding for future when you do more advanced classes. But for now, you must know that combination of n choose r is n factorial over n minus r factorial times r factorial. And the formula for permutations is permutation of n choose r equals n factorial over n minus r factorial. Until next time, as-salatu was-salamu ala rasulillah walhamdulillahi rabbil alamin. Assalamu alaikum.